Hi guys, welcome back to my channel. Hope you all are doing well. Today I'm going to teach you a new topic and definitely you will enjoy that topic, uh, properties of aluminium, and I will show a small demonstration how aluminium react with hydrochloric acid. I've already made one video on the magnesium, the reaction of magnesium with the hydrochloric acid. Let's see the physical and the chemical properties of aluminium. Aluminium is a light metal. Aluminium is present in the third group along with other elements: boron, aluminium, gallium, indium, thallium. As you move down the group, reactivity of metals increases. All are metals. Boron has both non-metallic and metallic character, so just ignore the boron. So metallic character increases down the group, and reactivity also increases. Reactivity of metals increases down the group. When you move down the group, it's easy to give away the electron. Now look at the aluminium. Aluminium has 13 electron and it has atomic mass 27. Aluminium is a light metal, very light metal. I will tell you the uses of aluminium later on. So 13, this 13 represents the atomic number, and 27 represent atomic mass. So this is nothing but total proton plus total neutron, and this is nothing but total number of proton, which is equals to total number of electron. It has 13 electron. Look at the structure of the aluminium nucleus. Then the first shell has 2 electron. Next it has 8, 1, 2, 3, 4, 5, 6, 7, 8, now total 10, 3 left, 1, 2, 3. So 3 electrons are present in the outer shell. That is why aluminium is placed in group 3 or group 13. No problem, 13 or 3 both are fine, because when you include a 10 element from the D block, and that is become first group, second group, 10 from the transition element or D block element, and this is third or 13. Now it has 13 electron, 3 electron in the outermost shell. So how can we write the electronic configuration of Al? Aluminium equals to 1s2, 2s2, 2p6, that is 10 electron, 3s2, 12 electron, 3p1. So it has 1 electron in the p subshell or in the px orbital. Okay, that's the electronic configuration of aluminium. Aluminium easily react with oxygen and form aluminium oxide. Formation of aluminium oxide is very important. Aluminium oxide prevents the rusting of iron. So we normally coat the aluminium oxide over the iron metal or iron bar, which prevents the rusting. Aluminium, all the metal gives away the electron. We know that. Aluminium react with oxygen and form aluminium oxide. This formation of aluminium oxide is very important. It prevents the rust. So it prevents the rusting of iron. Oh, I'm sorry. This is not total proton equals to total electron. That's not total proton is equal to total proton. Total electron. Any element of the periodic table has same number of electron and same number of proton, because normally the element is a neutral. The element is neutral because it has 13 electron and 13 proton. So 13 mean atomic number, which is equals to total number of proton and total number of electron. Okay, now aluminium react with oxygen. All the metal, when exposed to air, they react with oxygen. Here aluminium react with oxygen and form aluminium oxide, Al2O3. To figure out how to write the formula of any chemical compound, please watch my previous video. I have already taught how to write the chemical formula of any compound. Now look at that. So aluminium, make 2 aluminium and take 3 oxygen. So I need 4 aluminium, I think. Aluminium oxide, which prevents corrosion or rusting. Al, take 4 Al plus oxygen, take 3 oxygen and form aluminium oxide. So 2 aluminium balance, 2 times 3, 6 oxygen atom, 3 times 2, 6 oxygen atom, 4 aluminium balance. Or metals, any metal, metals plus acid. What we will get? Any guesses? We will always metal react with any acid. We always get salt. We get salt plus hydrogen gas coming out. This is gas and that's the salt. If we do aqueous, if we do this type of reaction in aqueous condition, the salt is liquid or aqueous, and hydrogen gas comes out. And we know what is the test of hydrogen gas. When you introduce any flame or a burning splinter, that splinter put it off with a squeaky pop sound. Now let's do one small practical or a small demonstration how the aluminium reacts with acid. Before that, what happened? Any means the student will ask me a question, what happens, sir, when aluminium reacts with water? Okay, aluminium reaction of aluminium with water, reaction with H2O. Aluminium react with water and form aluminium hydroxide, which is alkaline in nature. What's the chemical formula? AlOH in the bracket. Look at the reaction of aluminium with water molecule. When the aluminium react with water, it forms aluminium hydroxide. The nature of aluminium hydroxide is alkaline. We can test the alkaline nature by using the pH paper. Along with that, hydrogen gas coming out. So 2 aluminium balance, 6 times 12 hydrogen, 3 from here, 3 from here. Now it is balanced. So we will see. I want to do a small demonstration of aluminium reaction with hydrochloric acid. I have 1 molar hydrochloric acid that we will react, that we will see how this aluminium ball, I made the aluminium balls, all these aluminium balls, how they will react, how these aluminium balls reacts with hydrochloric acid. Let's do this small experiment. And what we have written here, I did not write. Look at the first, I'm going to write the equation and then we will see that reaction. So aluminium react with hydrochloric acid, all the metals, metal plus acid, we will get salt plus water. So what's the formula of aluminium chloride? AlCl3. Aluminium has 3 electron, so it gives away 3 electron, and chlorine gain 1 electron. So I need 3 chloride ion, AlCl3. So if we take 6, if we take 2 here, 2 AlCl3 balance plus 3 H2. So 6 hydrogen, it comes out as a hydrogen gas. 2 aluminium, 6 chloride atom or 6 chlorine, 2 times 3, 6 chlorine. Now, let's see that experiment, guys. And let's start our experiment. That is the reaction of hydrochloric acid with aluminium. about 1 molar solution of hydrochloric acid. What's the chemical formula of hydrochloric acid? HCl. It's 1 molar, guys. Look at the hazard symbol. It is corrosive and it is also irritant. So my strong suggestion is that don't touch any chemical without the supervision of your teacher. Now, I'm a professional teacher. That is why I know how to handle acid. When you're handling acid, you have to use your safety gadgets or safety gears like lab coat or apron, gloves, and always when you're using any chemical with my safety goggles, use the safety goggles. I'm taking a little amount of hydrochloric acid into my beaker. We are not doing quantitative experiment. It just it's just we have to see whether the hydrogen gas coming out or that hydrogen gas when we introduce burning flame, does it put it off or not. So a small amount of enough, and can we so I want to add and see how the reaction is going on. A small amount of HCl, quantity is not important, just a small amount of hydrochloric acid into my, assume that this is my conical flask, even though I have a conical flask, but this bottle has a small mouth, that's why I use this one. Small amount of hydrochloric acid, always the remaining amount of HCl or any chemical left, dab with the tissue paper or the towels, lap towels. Then okay, so I'm quite interesting. Sorry, I'm interested to add this a small ball of aluminium. I made this small ball of aluminium with the aluminium paper. So let's start. I made aluminium foil into a small balls, and I'm very excited to perform this type of experiment. So metal react with hydrochloric acid. So I'm adding all these aluminium ball into HCl. That's HCl. So I want to add all so that you can see the reaction quickly into acid, and we will see hydrogen gas coming out or not. Some more amount of acid. I'm not using the concentrated hydrochloric acid. If it will be a concentrated, the reaction is so vigorous and we can easily see the hydrogen gas coming out. I have added some more amount of aluminium, and I have doubled the amount of HCl to check whether the hydrogen gas is released when we add aluminium into hydrochloric acid. I know when you add aluminium into the HCl, aluminium form aluminum oxide because aluminium is exposed with oxygen. That aluminum oxide takes time to give away hydrogen gas. The reaction is very slow. The reason behind is I'm using diluted hydrochloric acid. If I would use conc hydrochloric acid, the reaction is vigorous, fast, and we can see the bubbles of the hydrogen gas. Hoping that I will do the same experiment by using conc hydrochloric acid. To do this, I have to do that experiment in the open place, guys. I don't want to use conc acid indoor. So sorry for that experiment. Next time I will by conc HCl, and we will do the reaction with the conc acid. But one thing, uh, I want to use the same dilute hydrochloric acid. I will show in my next video how the metal carbonate react with acid. Similar type of experiment. Any metal carbonate, when react with acid, we can expect salt. Salt is formed plus carbon dioxide gas. So not the hydrogen gas. We will get bubbles of the carbon dioxide gas with effervescence. We will see this experiment. My purpose of doing this experiment is to show how the metal reacts with acid and how the metal carbonate react with acid. What are the products we can expect when a metal react with acid? Any metal when react with acid, we can expect salt plus hydrogen gas. So any metal carbonate when react with acid, same amount of acid, same acid, we can get metal carbonate react with acid, so we can get metal salt and carbon dioxide gas liberated out and water molecule is formed. So I want to wind up this experiment, and I will come back with the same experiment, and I want to change the acid with the conc acid. Thanks for watching this video.